Now that we know about bigger bytes, let's write a program that uses more complicated data and operations. Let's write a cheat for Word with Acquaintances. Here's the problem statement. Word with Acquaintances is a word game where players draw letters and have to use their letters in combination with letters on the board to spell words. Players can draw wildcards that can be used to replace any single character. So we're going to write a program that's going to take a dictionary of words and use it to cheat by systematically finding all words that contain your letters. Now obviously I don't condone cheating, but things like this can be lots of fun to write. So the first thing we want to do is to create some test data. We could have very complicated test data, but I found in these cases it's better to keep it simple. So for example, A, B, 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 C, 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 and so on. Now at the end I did put in A, B, C, D, E. And the reason I did that is to help detect some more of the subtle errors that can come up when we're doing these programs. We should be able to find all the individual words in the dictionary when there are no wildcards. With one wildcard, we should be able to find all of those, but also find A, B, 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 C, 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 D, 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 A, B, C, D, E, B, C, D, E, C, D, E, B, and things like that. So we'll have lots of possibilities to check at the end. The first method that we're going to write is read dictionary from file. This method should look familiar because we just wrote a similar method. So I actually wrote this method in advance so we don't have to rewrite exactly the same code again. The algorithm is the same as it was last time. We read the file one line at a time and insert each word into the dictionary. Let's go and take a look at that method. So here's our read dictionary from file method. It's virtually identical to the one we've previously written. We construct a new array list, we construct a file, remembering that we also have to throw a file not found exception when we do that. We step through the file one line at a time, adding each element to the dictionary, and when we get to the end we return the dictionary. Now we expect this code is going to work well because it's identical to code that we just wrote that works perfectly. Up in the program, we created a dictionary.txt and an array list to store the dictionary we create and read dictionary from file. Let's go and take a look at the dictionary.txt. Notice it has the test data that we created on the last slide. Our next method will be find all matches. Now this one's going to be a little bit more interesting to write because it's a harder method. So we're going to need a string builder. That's going to tell us what letters you have. We're going to need some wildcards. How many wildcards do you have? 0, 1, or 2? And of course we need the dictionary. So let's start the body of that method. I'll grab the signature from the PowerPoint and pull it into Eclipse. It doesn't matter what order we put methods in. Now you may be wondering why I used a string builder instead of using a string. Well, the reason is that as we go through this code, we're going to have to find letters only once. So for example, if we have only one letter on the board that's an S, and we have a word that has 2 S's in it, that second S has to be a wildcard. So as we find letters, we're going to have to remove them. That's what string builders do. Remember that string objects can't be changed. So definitely this needs to be a string builder. Now Eclipse is doing something strange with the spacing, and that makes me think that maybe there's something here that isn't quite right. So right now I'm looking for all my curly braces and punctuation to see if anything is out of whack. It looks correct, so maybe Eclipse is just unhappy that we don't have a return type. We can fix that. So we just construct our object and return it at the end. Those curly braces are still bugging me, so I'm going to fix them manually. Let's also call our method so we don't have the disappointment of not seeing our program work. So we'll need letters, wildcards, and the dictionary. So these will be the letters that we pick. I'm just putting in some fake data for now. Eventually we'll want to write a user interface for this so people can actually play with it. We're going to need to save our array list. That comes out of find all matches to a variable called chosen words. And let's see what Eclipse is unhappy about. So what it's complaining about is that I thoughtlessly put a string here when in fact we needed a string builder. So let's make this a string builder. Remember, string builders don't have that easy construction syntax that strings have. So we have to actually build them using new, just like we do most objects other than strings. And the last thing we can do is actually print it out. I'm going to show you a little trick that we can use with print lines. We can just print out chosen words as one whole method. Now we don't control the formatting there so much, but it will give us a quick test to see that our program is working. Now let's talk a little bit about the algorithm. We're going to try to match the words in the dictionary one at a time. If the number of characters that match is less than or equal to the number of wildcards, that means that we have a word that could work with the letters that you have. Then the letters in the string builder have to be removed one at a time as we find the characters. Now, there are really two different methods that are fitting together in here. There's finding the match globally, and then there's finding the match within the words. These need to be separate methods because otherwise the find all matches method will get too long and complicated. So we definitely want to break those things out right at the start. So the third method that we're going to have will be called count matches, and it will take the string that's a word, so that would be the word from the dictionary, and the letters that you have. The algorithm for this one is stepping through the word one letter at a time. If the current letter of the word is in letters, we remove it from letters, and then we keep track of the number of letters that have been removed, because that tells how many we were able to use from the string. So let's create a stub for that method in the program too. Grabbing the signature from the PowerPoint. Of course, as always, our method is public and static. Here's count matches and our string builder for letters. And of course, to complete the stub, I put in return 0, just so that we get something back from the method. Now, it doesn't really matter which method we write first. We won't be able to test the code very efficiently until we have both methods available. So we might start with the one that we think is easiest, we might start with the one that we think is hardest, or we might just start with the one where the cursor is, which is what I'm going to do now. We're stepping through the word one character at a time. So we need an index, and it's going to start at the 0th character, while the index is less than word.length. Remember, we always want to increment the index at the end of the loop, so let's get that in there right now. If word.charat of the index is in letters. So we have to have a way of figuring out where it is in letters. Now this is a problem because we haven't used the string builder class as much, so you may not know the methods as well. So what we want to do is go to the API and take a look and see which method we should be using. We have the API up. looking for the string builder class. Learning to use the API is one of the most important things you can do as a programmer because it has so much information about what's available. The challenge to using the API is the fact that it isn't really written for beginning programmers. It's written for experienced programmers. So what you have to do is read as much as you can and just skip over the parts that don't make sense. That may feel like you're cheating, but you're not. You're just accessing the part that you can actually use now, and later on as your expertise in programming grows, you'll be able to understand more and more of the API. So what we're looking for is something that can tell us whether a character is in a word or not. Append doesn't sound very promising, so I'm scrolling down past all of the append methods that are there. Capacity doesn't. Char_at, while that's a very useful method, isn't really what we need. So we're looking for something that looks like it might do some kind of search. Now you might look under S for search, you could look under C for contains, or you can just step through the methods one at a time and see what works. So when we get down here, we will eventually find a method called indexOf. Returns the index within the string of the first occurrence of the specified substring. Well, those are a lot of words. But this is actually the method we want, because what it will do is it will tell us whether this string is inside of the other string. So we'll take the character that we have, we'll change it into a string, and then we'll see if that character occurs in the other string. Notice that when it doesn't find the substring, it returns a -1. Now that's going to be something we're going to want to look for in our code. We also might take a look just a minute before we go back and see if there's another version of indexOf that might be more useful. There are two versions here. One of them has a string parameter. The other has a string and a from index. So that one isn't going to be as useful. So we do have the right version of this. So let's go back to our code. We need to do a little bit of work here. We're going to have to create a string, which I'm just going to call char, because that's whoops, and I can't do that. Notice how Eclipse reminded me that I was cheating. The reason I can't call a string char is a reserved word. Remember, that's what single characters are called. So we have to find a different name for it. I don't want to call it letter because we have a string builder that's called letters. And having a variable called letter and a variable called letters in the same code is not a great idea. So let's call it mychar. So this will be word.char_at index. Now we've got a type mismatch here because we didn't construct the string. We're not allowed to just take a character and change it into a string. Now it's complaining about that too. It turns out there actually isn't a constructor in the string class that takes just a single character. So let's find an even more clever way to work around that. One of the easiest ways to change something to a string is to concatenate it to the empty string. It's a trick you definitely want to remember. So now what we want to see is if letters.indexOf, that's the method we looked up in the API, mychar is not equal to -1. Because when it's not equal to -1, that means we actually found the letter in the letters group. In other words, the letter in that word actually is one of the letters that we have in our list that we're trying to use. So when we find it, what we want to do is to remove it. Once again, we may not know the name for the delete method in the StringBuilder class, so let's go and look it up. I've sort of spoiled some of the suspense by telling you that the name is delete. So you can see we've got a couple of different methods. Here's a delete method that removes a substring, and here's one that just removes a single character. This delete char_at is the one we would like to use. So we'll do letters.delete char at, and the index, well, it will be the index of my char. Notice that because we want to reuse it here, we may want to create a variable for it. So let's revise our code a little bit. So we'll save our index, which I'll call chosen index, and then use it here. So we're deleting the character at chosen index. Okay, so let's think about anything else we might want to do. This removes the character, but we haven't kept track of how many matches we have. So that's definitely something we want to do. So let's say int matches is 0. And anytime we're deleting a letter from here, that means that we found another match. So we're going to want to increment match. The other thing I notice is that I cheated a little bit down here. I used an operator that you don't know. Plus plus index means index equals index plus 1. Let me fix that so the code looks familiar to you. Okay. Now we could use a few more comments in this code, so let's put some in. So we're going to step through the word one character at a time. Find if the word is, if the character is in the word. And instead of returning 0, we're going to return matches. So there we go. Now we really can't test this method by itself without writing a whole bunch of extra code. So let's just write the method that's going to call it. So that's the findAllMatches method that's here. We have a stub in for it, so we've got an array list that's keeping track of any words that match, and we're returning that array list. It does look like we got one too many tabs in there, or maybe two too many tabs. So let's fix that and beautify our code. Our algorithm was stepping through the dictionary one word at a time. So we'll have, say, int dictionary index. So that will start at 0 because all array lists are 0 indexed, while dictionary index is less than dictionary.size. Move over our curly braces to the right position. And dictionary index equals dictionary index plus 1. So that's our increment at the end of the loop. So what we want to do is to figure out if our string builder letters and with that many wildcards actually has that word in the dictionary. So let's go and take a look at the signature of the method that we just wrote. So we can copy it down here. So it's called count matches. The word is first and letters are second. The string builder is second. So the string will be dictionary.get dictionary index, and letters will come from the parameter. So we'll create an int called matches, and that will store that value. You may be wondering why it's okay for me to create another variable called matches when I had one in the other method. It turns out it doesn't matter how many different variables you have of the same name. And in fact, that's essential to programming. So as long as they're in different scopes, as long as they're in different methods, everything will be okay. So we've got our matches here. Now, if the matches plus the wildcards are greater than or equal to dictionary.get of dictionary index, so that's the word that's in the dictionary, dot length, well, that's when this is one of the possible solutions. So when that's true, what we want to do, and you can see that our code is getting a little bit long on the lines here, so we may want to make some adjustments to that later, is we want to add it to the result array. So we'll do result.add, dictionary.get, dictionary index, dot length. So that way we know that's one of the words that's going to count. Let's see what Eclipse is unhappy about. The method add is not applicable. Oh, okay. So what happened here is that I put in an extra dot length for some reason. There we go. Let's check our parentheses now. There's one before dictionary.get and one before dictionary index and 3 at the end. So I actually do have one too many indices hanging around. So that looks better. Now when I look at that code, one of the things I see is that we've called dictionary.get of dictionary index 3 different times in just a few lines of code. In fact, that's actually what's making the line so long. So let's clean that up by creating a variable for it. So we have a string, which I'm just going to call word, equals dictionary.get of dictionary index. Then here we can use word, and here we can use word, and here we can use word. So notice not only did this solve the problem with our lines of code, whoops, only you don't want the dictionary in front of it, of course. Not only did this solve the problem with our lines of code getting too long and awkward, but it actually makes the code considerably easier to read. It even makes it a tiny bit more efficient because referencing a single string is a little bit faster than going back and re-referencing the dictionary every time. It's just a little bit, and it doesn't really make that much difference in a program like this that you're really just using for fun, but still, it makes the code a tiny bit better. So let's take a look at our code again and make sure it's doing the right things. So we're stepping through the dictionary one line at a time. We get a word from the dictionary. We count how many times it matches. If the number of matches plus the wildcard is greater than or equal to the word length, that means it's one of the words that could be used in words with acquaintances. And then we go on to the next word. So that looks good. Let's check and see what we're returning. We're returning result. And let's go back to our main program and make sure we've got everything called correctly. Notice one of our lines of code got a little long here, so we're going to fix it. So at this point, we're not actually getting input from the user. We can always put that in at the end. Let's run the program once and see if we know what we're going to get. Now remember, AAAAA is in the dictionary, and so it should match by itself. So the chosen word that we should see at the end is AAAAA. Let's run the program and see if that works. Well, look at that, it did. That's wonderful. Let's try some of the other ones. Now at this point we've got a tough choice to make. We can spend the time to write a decent user interface, or we can just sort of patch one together. In the interest of time, let's patch one together. So we're going to have a scanner. Now this is a different scanner than the one that's later on in this program that's reading from a file. This is the one that's attached to the keyboard. So I'm calling it keyboard. So what we're going to put in here is a prompt. enter the characters you have, and then instead of doing this, we'll do keyboard.nextLine. One thing we might want to warn the user about is the fact that they can't enter spaces between their letters. That's something that is not obvious to them, so you do need to tell them. Without spaces. If you don't tell user things like that, they think your software doesn't work and then they get mad. And so that's not a good thing. Besides, you want them to use your software, so you need to make it easy for them. Now, we're also going to need to read our number of wildcards, so we'll prompt for that. And now, instead of just declaring 0, we'll read it from the command line. So that will be keyboard.nextInt. Now, if we were going to put this in a loop, which is probably what we're going to do next, we might want to think about what's happening with those end-of-line characters. So here in wildcards, we're reading an int, and the next thing that's going to be read in is going to be a next line. Remember, that's the case where we have to read in that next line separately. So even though we don't have our loop here first, let's think about it and be considerate and put that in now, because we'll be glad we did it later. So this is getting rid of the end of line character. This is part of a strategy that I use when I'm programming that's called anti-bugging. So you can spend a lot of time debugging your software, that is finding problems in it, or you can spend your time building software right in the first place. I'm a big fan of building software right in the first place. Okay, so now we're ready to run our program again. So of course, the first thing we want to check is the data we checked before, because that makes sure that the input that we just wrote is working. So here's our B's with no wildcards. Ooh, that was found. This is getting exciting. Let's do C with no wildcards. And it really feels good, right? Isn't it great? Well, hang in there. Let's do ABCDE with no wildcards. Okay, this is where having your test data done in advance is very important. Our program just failed. And if you did not have your test data in advance, and if you didn't have good test data, you might not have noticed it. For example, if you had only written one test example, like AAAAA or BBBBV, you would think your program's working correctly, even though it failed in this case. So this is a time to really pay attention to the fact that running a program once really doesn't demonstrate anything. This is especially important if you're turning in programs for grading, and of course critical if you're a professional that's creating programs. So what the heck happened to our program? This is not a simple problem, by the way, and these are the problems that students typically come up with when they're creating programs. So let's talk a little bit about how we can solve this problem. One strategy you'll notice that I'm not using at this point is just going in and randomly changing code around. Instead, I'm stopping, I'm thinking, I'm trying to find what the right answer is, instead of just going and saying, well, maybe it's this, maybe it's this, maybe it's this, maybe it's this. You're going to find that strategy, while it may seem more time-consuming, is actually much more effective. We have our tests, and we have to figure out how we're going to fix it. Well, the first thing we have to do is find the problem. And I'm actually going to use the debugger to help you find the problem here. So to do that, we go to debug mode, and we need to set a breakpoint in our code. So we have to think about where things could be going wrong. Our main program is pretty harmless here, so it is probably not the place where things are breaking. Let's get a little bit more space for our program than we're given by default in Eclipse. Our count matches seem to be working okay. It was finding the other data, so that probably isn't the problem either. The place where I am most suspicious is in the Find All Matches. This is a good place to stop. Now the question is, where do we want to stop the code? Well, this first line of code, the line that's on 67, that isn't a very good place to stop because we know the words are being found correctly in the dictionary. And we probably don't want to stop in the count matches. So somewhere right around here is about the right place. So I'm going to pick line 70. Incidentally, it wasn't letting me pick 69 because 69 is a blank line and it can't stop on blank lines because it doesn't process them. So what this will do is give us a possibility of looking at matches and wildcards and see what happens. Now to run a program in debug mode, remember, pick the little bug icon. If you hit the green run icon instead of the bug icon, you're not in debug mode, and then you won't see your breakpoints and you won't be able to debug. Here we go. Now, I'm going to move this down a little bit. The one that caused trouble was A, B, C, D, E with no wildcards. So here we are at our first breakpoint. Notice we can see letters. Let me give you a little more space here so you can see what it's doing. So this is sort of interesting. Notice that the value for letters is B, C, D, E by the time we get there. Well, wait a minute, what happened? Where did the A go? Now it's time to go back and look at the code very carefully. Now you can do this in debug mode if you want, but because you have so few lines of code, it gets a little hard to read there. So let's go back to the regular Java mode. We have an idea now that letters is getting messed up in the program. So let's go back and look at the code involving letters and see what's happening. Letters is passed in. Oh yes, and we should stop our program from running too, since we're not actively debugging it anymore. So let's start at the beginning. Where did letters come from? Well, letters came from the main program. Remember, we created a new string builder here from the keyboard input. That looks good, no problem with that. We passed it to Find All Matches. And inside of Find All Matches, we passed it to Count Matches. So notice that our thought that Count Matches was okay really wasn't correct. It turns out that Count Matches may be the source of our problem because letters is what's getting wrong. So let's think about what happens with letters in count matches. Well, we start out with all of our letters in there, and what we're doing as we step through is we're moving letters one at a time. So notice that on line 51, that's where we're deleting letters. Well, think about what happens when we find A in the dictionary. The first A is found, and it gets deleted from letters. And so at that point, letters has B, C, D, E in it, just exactly what we saw. Oh my goodness, we have a parameter passing problem. What happened is we passed in the string builder letters just once, and then we pulled out letters from many words and we didn't reconstruct it. So we're going to have to think about the possibilities for here of how to fix it. In other words, we can't take one string builder and share it through all three methods, because what's happening is partial results from one method are impacting the other method. That's a big problem. We have to think of a strategy. And once again, you want to think about as many possibilities as you can first. Don't just dive into doing something because it sounds good. One thing we could do is pass letters as a string instead of a string builder initially. Remember that strings can't be changed, and then the string builder could be constructed down in the count method. That would work. The other thing we could do is we could just create a new string builder object in the count matches method, and that would work too. So both of these solutions are good. I personally like the first solution a little bit better. That is, reading in letters as a string and only building the string builder down in the count matches method. The reason is that string builders, because they can be changed, tend to cause a little bit more problem. So it also keeps the interface a little bit cleaner. Most programmers are more comfortable with strings than string builders. So let's do that one. But remember, both of these would work, so there's more than one good solution. So we're going to have to go all the way up to the main program and change it one at a time. So instead of a string builder, what we really needed was a string. Now at that point, we don't have to use a constructor, so we'll remove that constructor and just read keyboard next line. Now the nice thing about this is that Eclipse will actually help you find all of the little pieces that don't match up right now. One at a time it will put little red lines under them. So if we go and fix those, it should be fine. So here we're sending in letters, which is now a string, but find all matches was expecting a string builder. So here's find all matches, and we're now going to give it a string instead of a string builder. Let's see if there's anything else that needed to be changed. Well, notice count matches now isn't working for the exact same reason. So let's go up to count matches. And make letters a string instead of a string builder. Now, inside the logic of count matches, we need that string builder. So let's create it here. So I'm going to call it SB letters, SB for string builder. It's not the greatest variable name ever, but it'll do. So there we've got our new SB letters. And now we need to think very carefully about how this is going to work. So that string is the same, chosen index is the same. Now instead of letters here, we're going to need SB letters. That is our new string builder. Now the delete charet method should be, oops, maybe I gave it a little different name, so let's go and take a look. SB letter. Let's call it letters to be more consistent. Okay, so now everything looks better. Of course, the final acid test is whether our program works correctly now. We know the test data that failed, so let's run that data first. So A, B, C, D, E with 0 wildcards. Oh no, look at that. Reading these error messages can be hard work. What you don't want to do is go and click on things like this. What this is saying is that we had a string out of bounds exception that occurred. In other words, we tried to access a character in a string that wasn't there. We're not allowed to do that. If you click on this though, right there, what it will do is take you to the string index out of bounds exception class. Well, let me tell you something, the error is not in that class. That's part of the standard Java API. The error is virtually certainly in the code we wrote. So what you look for is the method that's in the code you wrote, which is not abstract string builder, which is not string builder, but right here in Words with Acquaintances, line 53. So that's interesting. That letter we just changed is the one that's causing the problem. So let's think about what could be happening here. Well, we're stepping through the word one character at a time. We find the character in the word index. We find the index of it, and that's our chosen index. Then we say if it's not -1, delete chars at the chosen index. Well, what could possibly be going wrong with this? So this is really perplexing. When you look through it, you'll see that we created a string builder called SB letters, but when we were finding chosen indexed, we used letters instead of SB letters. So notice that our fix caused another problem. This is actually incredibly common in computer science. In fact, when you fix a bug in commercial code, the probability of creating a new bug turns out to be 50%. This is one of the reasons that programs don't tend to be perfect, is because fixing bugs tends to cause more bugs. And that's exactly what we did here. What we did was we changed letters to SB letters in many places, but we missed one. The reason we missed it is that it's actually legal to use index of both on a string builder and on a string. And so Eclipse wasn't able to help us out with that. So we needed to be reading code a little bit more carefully. So here is SB letters instead of letters. Let's run our program again and see if it's behaving better. A, B, C, D, E with no wildcards, and yay, it's found. Good enough. Now, we do still need to rerun all of our original test data, because remember, we don't know that that data works. We also haven't tried anything that has any wildcards in it. That one works too, 5 A's with a 0. So let's try one with some wildcards. Let's do ABC with 2 wildcards, and it found A, B, C, D, E. We would have to keep testing to make sure that our program is really correct, but the results are looking promising right now. So I'll let you do the rest of the testing on your own.